Okay, here we have regular water and magical miracle water. And just to make things more interesting, here we have regular water ice, and here we have magical miracle water ice. Now the interesting thing is that if you take regular water ice and put in regular water, it floats. But and if I take regular water ice and put it in magical water, it also floats. But if I take magical miracle water and put it in magical miracle water, it floats. But if I take magical miracle water and put it in normal water, it sinks. But not only does it sink, it doesn't melt. Right? And just to really push this point home, that's it floating in regular water, and that's it sinking. Sorry, that's it floating in magic water and sinking in regular water. Whereas with regular water ice, floats in regular water. But let's look at this a little more closely. It's actually much more buoyant. It's actually sort of super buoyant. You can see that in magic water, and I'm going to call that normally buoyant in regular water. So what the hell's actually going on here? Well, what's actually going on here is, obviously, it's not really magical water at all. So let's actually put our sinking water in there, because not only will that sink, it will also not melt. Right? So what the hell's going on? So, right, regular water is of course H2O, and so that's H2O, and this one is heavy water, so that's deuterium oxide. Now both of these waters actually have more or less the same quasi-tetrahedral structure, where of course the water molecules are actually on the vertices like this. So both actually have the same quasi-tetrahedral structure as a liquid. But of course deuterium weighs 2, oxygen 16, deuterium is number 2, and whilst with regular water this is 16 for the oxygen and both of the hydrogens are 1. So that's got a molecular weight of 18, and that's a molecular weight of 20. So seeing as the actual structure of both these things is essentially the same, the practical upshot is that has a density of about 1.1 grams per cubic centimetre, whereas regular water has a density of about 1 gram per cubic centimetre. So what this means is that heavy water is about 10% more dense than regular water, even though the number of atoms per unit volume is exactly the same. It's because deuterium weighs more than hydrogen. Now there's some other interesting properties to all this. For instance, if you take a beaker of water and you put some ice in it, so let's take a beaker of water and put some ice in it, what you find is your sort of typical iceberg ratio that about 10% of your water actually sticks out at the top, which means that the densities of ice is about 10% less than that of water. So water, ice, has a density of about 1 gram per cubic centimetre. Ice has a density of about 0.9 grams per cubic centimetre. So this brings about the interesting question. What happens if you put frozen D2O into regular water? Does it float or sink? Right, so you actually reduce this by about 10%. That means that D2O ice is going to be about 1 gram per cubic centimetre, whilst regular water ice is going to be about 0.9 grams per cubic centimetre. And the answer is that D2O ice, as you can see, sinks. Right? D2O ice sinks in regular water. But not only does it sink, there is another curious property about D2O, is the physical properties are slightly different. So it turns out that D2O freezes about 3 degrees C, whereas of course water freezes at 0 degrees C, which means that if you put D2O ice into regular water at the right temperature, about between 0 and 3 degrees C, not only will it sink, but it will also not melt. Well, not at any significant rate anyway. And just so you know, the deuterium oxide actually runs at about $1 a gram or something, $2 a gram for the expensive stuff. So the the practical upshot is that's about $20 worth of D2O. Now it turns out this is all sort of waste from an experiment that I've done, but it is nonetheless an interesting question. This is essentially an experiment done by an Englishman in a French laboratory with material supplied by the Americans. So who takes credit for this?